Hey guys, this is Mr. Lowry. I wanted to give you some key ideas from our day one lesson. So if you're an A cohort, this is the lesson we did in class on 125, which is a Monday. If you're in B cohort, this will be for 126, or January 26th, which is a Tuesday. Today's topic is special right triangles. And last week we were talking about right triangles because we're using Pythagorean theorem. We're going to continue our discussion of right triangles. So I'm going to give you a few key ideas here that we talked about in class, and then also do some example problems from your homework. So if you were in class and you already got this, you may want to skip ahead a little bit and look at some example problems. If you missed class, then this might be good to have down. This is kind of the Cliff Notes version, so not maybe a little less than we talked about, but hopefully enough to get you going. Okay, first of all, what is a special right triangle? What does that mean? Well, of course, right triangle means that it has a 90-degree angle, okay? But a special right triangle really is a common right triangle. It's a right triangle that we use often in like art, construction, architecture, design, things like that, okay? So special right triangle is a common right triangle used in, you'll see it all over the place. Art is a big one, construction, like if you're building, bridges, or you're building a house and you're trussing up sides of a house. Design in general, so product design or art design, graphic design, things like that. Architecture, etc. All right, lots of different things. They're so common that we're going to memorize the side ratios, okay? So we memorize the side relationships because they're used so often. Okay? And there's two of them here. There's the 45, 45, 90 and the 30, 60, 90, and these are referring to the angles of the triangle. Okay? So let's draw the 45, 45, 90 and kind of what it looks like. So in a 45, 45, 90, you have 90-degree angle, of course. And then the other two angles are both 45 degrees. Okay, so 90, 45, 45. Now the interesting thing about the 45, 45 is if these two angles are both 45, then the sides that are across from them must also be equal in length, right? You think about this 45-degree angle opening up here and this 45-degree angle opening up here, these sides have to be the same length. So this also makes it an isosceles triangle. So the 45, 45, 90 is also an isosceles right triangle, okay? Isosceles means two of the sides are the same, right means there's a 90-degree angle. Okay, so if you think about, how often this triangle comes up in art or science or, construction, architecture, it's very, very common. In fact, there's actually a tool that looks kind of like this that's used for drawing right angles when you're drafting out like blueprints or whatever. Okay, now another key idea is that every 45, 45 degree 90 triangle will be similar to all the other ones because they all have the same angles, right? So if I had a bigger 45, 45, 90, it would be similar to this because, again, all the angles are the same. So I'm going to make myself a little note here that all 45, 45, 90 triangles are similar to each other. Okay? So I don't know if you can see this, but I've actually drawn kind of I had a fold here because we're kind of going to do, one on the side, one on the side. So what I want to do is I want to kind of explore the relationships between the sides here, and I want to do it with a basic example and then a more, bigger examples. Okay, so let's do a basic example here of the side relationships. So I'm going to kind of draw this guy out again. Okay, not perfect, but I'm going to label that a right angle. We'll call it good. So we're going to call this side 1, and that means this side has to be 1 as well. Remember that these are isosceles triangles. So I'm just going to do a basic one where this is 1 and this is 1. Okay? If that's the case, what we want to do is we want to find the other side here. Okay? So this is leg, right? Leg equals 1, leg equals 1. Remember the leg forms the L. Okay, across from that is the hypotenuse, across from the 90-degree angle. So we can use Pythagorean theorem here to find the missing sides, right? So 1 squared, leg squared, plus the other leg squared, 1 squared, is equal to the hypotenuse squared. Okay? Well, this is 1 plus 1 equals hypotenuse squared, or 2 equals hypotenuse squared. Okay, to get just the hypotenuse, I need to take the square root on both sides, which gives me the square root of 2 equals the hypotenuse. Okay? Doesn't come out nice. It's an irrational number, but that's okay. This is the relationship between the sides. Now, a bigger triangle, a bigger 45, 45, 90 will have bigger sides, but the relationships between the sides will be the same because all 45, 45, 90 triangles are similar. And if the triangles are similar to each other, then their sides are in the same proportion. Okay? So let's do a scaled example. Okay, this is a basic one, but what if we were to scale it up, right? Like what if we were to multiply all the sides by, let's say, 10? So we'll do a factor of 10, a scale factor of 10. So we're just going to scale up the triangle, we're going to blow it up, okay? Well, if that's the case, the relationship between the sides will still be the same. All the sides will just be 10 times bigger. So this will be 10, right? 1 times 10 is 10, and this will be 10 times bigger. 1 times 10 is 10. These will still be the same length as each other, okay? And then this guy right here, we'll have to multiply this by 10 as well. So 10 times the square root of 2 is 10 root 2. Okay, let's add the angles in here. Okay? Notice, though, that the relationships between the sides are the same, right? Like here, if I take this guy and multiply it by root 2, I have the hypotenuse. If I take 10 and I multiply it by root 2, I'll have the hypotenuse. Okay? So the hypotenuse in a 45, 45, 90 triangle is always this number bigger than this many times, right? Square root of 2 is just a number. It's about 1.41 or so, but it's irrational. And the hypotenuse is always square root of 2 times bigger than the leg. Okay? So let me give you a generic example, okay? And this is what we want to use. This is what we're going to use on our homework. So in general, if we scaled this triangle, let's say we don't want to pick a specific scale factor. We're just going to pick a generic scale factor. We're going to call it x. Okay? If we took our original triangle here and we multiplied each side by x, this side would be x, and this side would be x, because 1 times x is x and 1 times x is x. And then this side would be x times the square root of 2. That is how we represent the relationship between all of these sides. Okay, this is the relationship no matter what. The sides can be any length, but this is the relationship between them. Okay, so what we can do here is if we know one of the legs, we can easily find the hypotenuse. All we have to do is multiply by the square root of 2. Okay? Now, going the other direction, let's say we knew the hypotenuse and we wanted to find one of the legs. Well, all we would have to do is do the opposite. We know this guy's bigger, square root of 2 times bigger. So if we want to go the other way, we just need to divide by root 2. Okay? This is super important for what you're going to do on your homework. Okay? This is super, super necessary. So make sure you have that. Okay? Now we're going to use that on our homework. So let's jump over to a homework really quick and let's take a look at a couple examples. Okay? On your homework here, we have a bunch of triangles. The first 8 are 45, 45, 90. So I'm going to draw a line here because these are all the same kind. We're going to come back and talk about the other kind in just a second. Okay. So let's take a look at this guy really quick. In the first one, we have an 8 here on the side. One of the legs is 8. Okay? Well, the relationship in the sides of a 45, 45, 90, which this is that the legs are the same as each other. So that means that V has to equal 8 too, this side. Okay? Also, the hypotenuse is always square root of 2 times bigger than this guy. So if I want to go from, if I have a leg measurement and I want to know the hypotenuse measurement in a 45, 45, 90, all I have to do is multiply by the square root of 2. Okay, so what's 8 times the square root of 2? It's 8 times the square root of 2. Okay? All right, now that's a pretty easy example, right? So let's make it a little bit more complicated. Okay, let's take a look at number 3. Okay, in number 3, again, I have one of the legs. Okay, according to what we wrote here, the legs are always the same length, right? This means it doesn't matter what it is. This is x, this is x. Okay, so if this is 2 root 2, this is 2 root 2. Okay, now don't get confused. This has a root 2 in it, right? And root 2 is one of our special numbers that we use to multiply by. But that's okay. This length can be, this leg length can be whatever we want it to be. It's 2 root 2 is fine. The point is, how do we get from one of the legs to the hypotenuse? Well, the pattern here, what this is saying is that this side, the hypotenuse, is always root 2 times bigger than whatever this side is. So if this leg is 2 times the square root of 2, I have to take this guy and I have to multiply it by the square root of 2. And that's okay. Like, it doesn't matter what the side is, okay? So what we have is u is equal to 2 root 2 times root 2. Now we just have to worry about simplifying, okay? So this 2 right here, this is multiplying this root 2. So if you want, you can put a times there as well. We don't usually leave that there at the final answer, but this is 2 times the square root of 2 times the square root of 2. Okay, and this stuff we can deal with. Okay, so there's a couple ways to think about this. Square root of 2 times square root of 2 is just 2, right? Because we're multiplying 2 of them together. That undoes the square root. But if you're kind of uncomfortable with that idea, you can just say, okay, square root of 2 times the square root of 2 is the square root of 4, which is just, this part is just 2. So I got the 2 on the outside, square root of 4 simplifies to just 2, and then I just got a regular 4. Okay, so u is equal to 4. So we got to multiply, we got to simplify as well. All right, so this is the leg length, this is the hypotenuse. Okay, if the leg length itself is a radical, then sometimes what happens is the hypotenuse won't be. And that's okay. It doesn't matter, you know, which is irrational and which isn't irrational, as long as that you use that relationship. Okay? Let's look at a couple more. Okay, number 5. Now notice here, actually let's look at number 6. It's a better example. Okay, so now here we have the hypotenuse, right? And what we want is a side length. But what we know, based on our figure here, is that this guy, the hypotenuse, is always square root of 2 times bigger than this one. Okay? Now notice there's not a square root of 2, like you can't see it, but that's okay, it doesn't matter. What we're going to do is we're going to divide by square root of 2, right? If we want to go from the hypotenuse to one of the legs, we have to divide by square root of 2. Okay, it doesn't matter that you don't see a square root of 2 in here, you still divide by square root of 2. And so what we have here is x equals 8 over square root of 2. Okay, that's it. Now from here we have to simplify a little bit, but that's not, it doesn't have anything to do with the triangle. Right? The triangle part is done. We've used the triangle, we have that relationship. The rest of this is just cleanup. Okay, so what we have to do here is what's called rationalizing the denominator. We don't want to have radicals in the denominator, no roots in the denominator. So what we think to ourselves is, okay, if I were to multiply this by something to get rid of the radical, what would it have to be? Well, in this case, we'd have to multiply it by root 2, because root 2 times root 2 is 2. Just like we saw up here, right? Root 2 times root 2 is that 2 right there, or in other words, square root of 4. So root 2 is the number that I need to multiply root 2 by to get rid of the root. Now, if I multiply by root 2 on the bottom, I also have to multiply by root 2 on the top, because that makes this piece right here just a 1. If you think about it, root 2 over root 2, that's just a 1. So what we're doing is we're using the multiplicative identity property, which says if you take something and you multiply it by 1, you get the same thing. Now our thing is going to look different, but it's going to have the same value. Okay, so 8 root 2 on the top, 8 times root 2, or 8 times the square root of 2. On the bottom, I have the square root of 2 times the square root of 2, which is just 2. Okay, if you need to do an extra step there, the square root of 2 times the square root of 2 is the square root of 4, right, which is equal to 2. Or another way to think about it is the square root of 2 times the square root of 2 is the square root of 2 squared, right? And the square and the square root undo each other. That's the whole thing, why we want to multiply by the square root of 2. All right, from here, 8 over 2, that simplifies, right? This is just a regular 8 and a regular 2. It just happens that this 8's multiplying this guy. So since 2 goes into both, 2 goes into 8 4 times, 2 goes into 2 1 time, we don't necessarily need to write the 1 on the bottom. Okay, there's your x. So again, the first step, if you're going hypotenuse to leg, just divide by square root of 2. Okay, everything else after that is cleanup. It's rationalizing the denominator. Now, we've already studied this. We studied this last semester, so hopefully this is familiar, but I wanted to, again, just kind of walk through that so you know. Okay, if x is 4 root 2, then y also has to be 4 root 2, because remember, the legs are the same as each other in a 45, 45, 90. Okay, cool. Let's take a look at one more. Let's take a look at number 7 here. Okay, in number 7, actually let's do 8 because you have the answers to the odds. So I'm going to do number 8 here, and then you can do this one and check on your own. The same situation's going on here, right? We have a root 10. Okay, we want to divide by root 2. Okay, that's the relationship. If you want to go from the hypotenuse to the leg, the hypotenuse is always square root of 2 times bigger, so you need to divide by square root of 2. All right, over here, that's going to give us the square root of 10 over the square root of 2. Okay. Now there's two ways to think about this. You can either rationalize the denominator, which is fine. You can also just put these guys in the same root. Okay, so since these are both square roots, the square root of 10 over the square root of 2 is the same thing as the square root of 10 over 2, where both of these things are in a single root. And 10 over 2, of course, is 5, so this is just the square root of 5. And if this is the square root of 5, then this better be the square root of 5 as well. Okay, now if you were to rationalize the denominator, that's okay. So 10 root 2 over 2, let's say you're like, okay, let's do this move again. Okay, that'll work out just fine. What you're going to have here, though, is you're going to have the square root of 20, and then this is going to be a 2, but this can simplify, right? The square root of 20 is actually 2 root 5, and so when you simplify the square root of 20, you're going to get 2 root 5 over 2, cancel out the 2's, and you still get root 5. Okay, so however way you slice it, you're going to end up with x is equal to root 5 and y is equal to root 5. Okay, so on 1 through 8, there's only 2 moves. The moves is either multiply by root 2. If you're going from a leg to hypotenuse, you multiply by root 2, right? Multiply by root 2. If you're going from hypotenuse to leg, you're dividing by root 2, dividing by root 2. Everything else is dealing with the radicals, and that's, you know, stuff that we've studied before last semester. We're just kind of practicing here. Okay? All right, let's take a look at the second kind of triangle here that we have to deal with, and then we'll do a couple examples from this guy. Okay? Just like we did over here, we're going to kind of build this ratio as we go. Okay. Let's start with, this is kind of the easiest way to think about this. Let's start with an equilateral triangle. Okay. An equilateral triangle is a triangle where all the sides are the same. If that's the case, though, all the angles have to be the same. So this angle, and this angle are all the same. And since they have to add up to 180, that means all of these guys are 60. 60, 60, 60. Okay, let's call this side length a 2. This is going to be kind of getting into our basic example here in a second, but we're going to start here. Okay. Now what we're going to do is we're going to draw what's called an altitude. Okay, an altitude is a line that you draw at a 90-degree angle to one of the sides of the triangle. And this is going to split our triangle up, okay? So if we, look at 1/2 of this triangle, This isn't perfect, but we're looking at this half. This is a 2, right? 2. And this is still a 60, right? 60. But we split this angle, this 60-degree angle, in half, and so now this guy right here is a 30. And we also split this whole side that was a 2. I'm just looking at half of it now. So this is a 1. Okay? So here's a hypotenuse. And here's a leg over here. So hypotenuse equals 2, leg equals 1. The question is, what's the other leg? Okay, so this is the basic example of the 30, 60, 90. We have a 2 here, we have a 1 here. We don't know what we have here. We're going to use Pythagorean theorem. Okay, so setting up the Pythagorean theorem, we go 1 squared plus the other leg squared, but I don't know the leg this time, equals hypotenuse squared, but I know the hypotenuse is 2. So 1 plus leg squared equals 4. So leg squared equals 3 if I subtract 1 from both sides. And then when I take the square root on both sides, I get that leg is equal to the square root of 3. Okay? So this is your basic example of your 30, 60, 90. You kind of start with an equilateral and then split it in half. That kind of helps. Okay? So here's your 60, here's your 30. Okay, it's kind of hard to see. I'll draw a bigger one in a second. But this relationship, like the sides aren't always the same length, but the relationship between the sides is always the same. So let's scale it up. Okay, we have a basic example. Let's do a scaled example. Okay, in our scaled example, let's multiply it by, let's say, 100. Okay, so our scaled example is going to be 100 times bigger. Now, of course, we can't draw it to scale because 100 times bigger would be too big. But let's say that the short leg, right, there's a short leg, there's a longer leg, and then there's the hypotenuse. Okay, let's say the short leg is 100. Okay, the short leg is always across from the 30-degree angle. Okay, the longer of the two legs is always across from the 60-degree angle. And then the hypotenuse is always across from the 90-degree angle. Okay, so if this one is 100, this one has to be 200 because the hypotenuse is double the leg length, right? If this is 1, this is 2. So if this is 100, this is 200. We're just multiplying all the sides by 100. Okay, so on this side, the longer leg, this would have to be 100 times the square root of 3. Okay, the square root of 3 is just an irrational number. But the relationship is if this is 1, this is the square root of 3. So if this is 100 times bigger, then this has to be 100 times bigger as well. And this side is always, the longer leg, is always is always the square root of 3 times bigger than the short leg. Okay? So let's take a look at how it looks in general. Okay. So in general, and we can draw this triangle in any formation. I ended up taking the left-hand side, but it could just easily be the right-hand side. Let's draw it like the other one just to be consistent here. So it doesn't really matter what orientation we're in. It doesn't really matter what way the triangle's facing. In fact, on your homework, they're going to be facing all different kinds of directions. Excuse me. Okay. So here's our 90 degree. Remember that the short leg is always across from the 30-degree angle, and the long leg is always across from the 60-degree angle, and then of course the hypotenuse is always across from the 90-degree angle. Okay? So if the short leg is x, the hypotenuse would be 2x, because the hypotenuse is always 2 times the short leg. It's always twice as long. Okay? If the short leg is x, then the longer of the two legs, like these are the two legs, the longer of the two legs is x times the square root of 3. Whatever this number is, you multiply it by the square root of 3 and you get this one, right? So if this is 100, this is 100 root 3. Okay? Now let's talk about how we get around, just like this thing over here. If we have the length of the short leg and we want the length of the hypotenuse, all we got to do is multiply by 2. If we have the short leg and we want the longer leg, all we got to do is multiply by the square root of 3. Okay? And then opposite if we go backwards. So because there's two different things where, like here's there's only one, right? Multiply by root 2, divide by root 2. Here there's two different numbers. There's a 2 and a root 3, but we also need to be able to go backwards as well. So just for, just to make it a little bit more clearer, otherwise we're going to have arrows going all over the place. I'm going to draw this again. Okay, now this is just kind of a rough sketch, right? Here's the bigger angle, here's the smaller angle. Okay, here's x, here's 2x, here's x root 3. Okay, let's say I knew the hypotenuse length and I wanted to go back to the short leg. Well, I just have to go backwards, right? Divide by 2. Let's say I knew this guy, the longer leg, and I wanted to find the shorter leg. Well, I just have to go backwards. I have to divide by root 3. Okay, so short leg to hypotenuse, multiply by 2. Hypotenuse to short leg, divide by 2. Short leg to long leg, multiply by root 3. Long leg to short leg, divide by root 3. Okay, this stuff right here, from here down, all this stuff below this line, this is stuff that you're going to need to know. This is what you're going to use on your homework. You have to know these relationships, otherwise you can't get around. Now you should probably memorize them because they're going to be on, tests and quizzes and stuff, and it'll be easier if you have them memorized. But for now, use this as a guide. Use this as your guide to help you in your homework, and as you practice, you'll start to remember. Okay? Let's look at a couple here. Okay. Again, I'm going to save the odds for you and do a couple of the evens because I think that these you have the answers for and you can check them. Okay? So let's take a look at this guy. Okay? It doesn't have the 30-degree, it doesn't have the 60-degree angle measurement, but it doesn't matter. If this is 90 and this is 30, this has to be 60 because they all have to add up to 180. Okay? So here's the short leg. Okay? If I want the hypotenuse from the short leg, what do? If I want the hypotenuse and I have the short leg, I need to multiply by 2. Okay? The hypotenuse is always 2 times as long as the short leg in a 30, 60, 90. Okay? So I take this guy and I multiply by 2 times 2. That means m is equal to 8. Okay? If I want the longer leg from the shorter leg, I multiply by root 3. So again, taking a look at this, right? Short leg to long leg, I have to multiply by root 3. It's in a different position. That's okay. It's on its side. But I'm going to multiply by root 3. So this is 4 times root 3. So n equals 4 root 3. M equals 8. There's your missing sides. Okay? Again, every 30, 60, 90 right triangle is similar to every other 30, 60, 90 right triangle, which means that the sides are always in the same proportion. They always have the same relationships to each other. Okay, let's take a look at 12. Okay, so here's 30, right? 60, 90. This is the short guy. Here's the hypotenuse, and here's the long leg. Okay? Again, hypotenuse to short. Let's go back and take a look at this guy. Hypotenuse to short, I'm going to divide by 2. So 7 divided by 2. Divide by 2. So this is y is equal to 7 over 2. We're going to leave it as a fraction. Okay? In order to go from the short side now to the longer side, it's just like we did over here, right? Short leg to long leg, excuse me, I shouldn't say side, because the longest side is the hypotenuse. But what I'm talking about is the short leg to the longer leg. Okay, I need to multiply by the square root of 3. So times by root 3. 7 over 2 times root 3 over 1 is just 7 times root 3 over 2. Okay, so x equals 7 times root 3 over 2, and then y is equal to 7 over 2. Okay, so not too big of a deal. Now sometimes you're going to have, all kinds of different, like you could have some irrational numbers here, right? That's okay. And then in the last 4 you actually have, or the last 6, excuse me, you actually have 2 triangles in there, right? So let me show you how to do one of those. You're going to actually have to use both ideas, okay? In order to find x, I need to know what this side is. But this is a 45, 45, 90. So this is actually 2 moves, okay? Let's start with the triangle that I have a measurement for, right? Notice that I have no measurements on this triangle. I'm going to start with this one. Actually, sorry, I should start with this guy. Again, because 17 you have the answer for. Let me do the evens for you so that you can check your answer here. So again, 45, 45, 90, right? Okay, and then I have a 30, 60, 90 here. So you always start with the triangle that you have a side measurement for. Okay, what you want to find is the side that they're sharing. Okay, so side that you have to side that they're sharing, and then side that they're sharing to the missing side. So in this 45, 45, 90, if we ignore the other guy for a second, what's the relationship here between the hypotenuse and the leg? Here's our 45, 45, 90. If I want to go from hypotenuse to leg, I need to divide by root 2. Okay, so I need to take 9 root 6 and divide it by root 2. All right, well again, we're going to use property of roots here. So this is 9 over the square root of 6 over 2. So I'm combining these two guys in the same root because it's the same kind of root. It's like both square roots. All right, so this is 9 root 3. Okay, so this side right here is 9 root 3. But now I'm looking at this triangle, okay, and this is a 30, 60, 90. So here I have 9 root 3 for the long leg, and I want the shorter leg. Okay, so now I look at the other kind of triangle, and I want to go from the long leg to the short leg. And I do that by dividing by root 3. So I got to take 9 root 3, this guy, that long leg, and divide it by root 3, and I get the short leg. So x is equal to 9. So it's just a two-step process, right? Start with the 45, 45, 90, find the side length, and then use that, because the two triangles share that side, to find the other one. Okay, let's do one more. This time, in number 20, we actually have the 30, 60, 90 first. Okay, so we want to find this side. We want to find the side that they both share. So we want to go from the hypotenuse here to the short side here. The hypotenuse of the 30, 60, 90 to the short leg of the 30, 60, 90. Okay, so I know it has a square root of 3 in there, right? That's kind of confusing, but let's take a look at what we're supposed to do here. Let's use our guide. Okay, from hypotenuse to short leg, I need to divide by 2. Okay, divide by 2. That's all we're doing. So I need to take 7 root 3, that's the hypotenuse length, and divide it by 2 in order to get this side. Okay, so this side right here is 7 root 3 over 2. Now that's kind of tricky, right? Because you think, wait a minute, doesn't this guy have a square root of 3 in it? It does. One of the relationships between the sides is the square root of 3 relationship between the short and the longer leg. But this length right here, it can be whatever length. It can be whatever length. It can be any length. And so this square root of 3 is just a number, right? 7 times the square root of 3 is just a number. So you will see sometimes those other radicals in there, and they could be similar numbers to what we have in here, but again, use your guide. And this says to go from hypotenuse to short leg, I divide by 2. Okay, so that's my short leg, right? Okay, now I want to go from, I need to look at the other triangle. So now I'm looking at the 45, 45, 90. Okay, and this is the hypotenuse of the 45, 45, 90, and I want the leg. Okay, so we started out with this guy, and now we're looking at this guy. Okay, in the 45, 45, 90, if I want to go from hypotenuse to leg, one of the legs, doesn't matter which one because they're the same, I need to divide by root 2. So this is 7 squared root of 3 over 2, and I need to divide by root 2. Okay, that's the same thing as multiplying by 1 over root 2. Right? So dividing by a number is the same as multiplying by the reciprocal. So this is the same as dividing by root 2. Or not, either way you want to do it, however you think about it, you're going to have square root of 3 over 2 times root 2. Okay, so you're going to have a root 2 on the bottom. Now we have to rationalize. So we're going to multiply by root 2 over root 2. We don't care about the top root. What we care about is getting rid of the bottom root. Okay, so on top, we're going to have 7 times the square root of 3 times the square root of 2, or 7 times the square root of 6. Sorry, that's an equal sign. on the bottom, we're going to have 2 times the square root of 2 times the square root of 2. Okay, now these two square root of 2 together, you multiply square root of 2 times square root of 2, you get 2. But there's this other 2 already. So it's this regular 2 times the 2 that comes from these two guys. That's going to be 4, right? And now this is our simplified answer. So I'm just going to put it over here because I ran out of room. So 7 root 6 over 4. Now if there's anything that simplifies with the 7 and the 4, we could do that. But since 7's prime, we can't really do that. So this is what we're gonna stop there. All right. So on the two-steppers, again, start with the triangle where the side's labeled. Find the side they have in common. So in this case, I'd have to divide by root 2 again, right? It's 45, 45, 90, divide by root 2. Okay, rationalize, of course. Then you need to go from that side to this side, in which case you'd have to multiply by root 3. So short leg to long leg, multiply by root 3. Okay, that's the setup for that guy. So that should help you get going, but really it all comes down to this stuff right here. Okay, this is how you're going to navigate around. This is how you're going to move from one side to the other. So have this written down somewhere, have it handy, put it in your notes if it's not already there. The only other thing you have to worry about with this is just, how do you divide by a square root 2? Like, how do you rationalize the denominator? How do you rationalize the denominator if you divide by a root 3? And how to deal with radicals. So I wanted to give you some practice with that, but that should help you get going. Make sure that you show your work. Make sure that you take a picture of this and submit it via Canvas, and then make sure you put the hard copy in your notebook. Thanks for watching.